Okay, welcome back to my programming in ARM assembly video series that I'm doing. So let's just go ahead and jump right back into the code. Let me just fix this window really quick. Now this is actually the second time I'm having to re-record this because unfortunately I had my microphone all messed up the last time. So as you can see here, I've recopied vid3 back over top of main, so all the changes I made would be reset, but that's okay because now I'm just going to be more efficient at doing what I did last time. But let's just go ahead and jump back into it. So in the previous video that you guys got to see, I was having issues getting this logic worked out, and the TLDW, the too long didn't watch version, is that I need to first of all, I need to swap these values here because it turns out that this register and this register can't be the same. And what I ended up needing to do was loading register. I need to multiply register 4 times 10 and then add register 3 to it. Because if we walk through the logic, here's how that works. Let's say we only enter in a single number like 5. So register 4 gets initialized to 0, register 5 gets initialized to 10 for our multiplier, and then we pick out the byte that was typed in and we save that into register 3. So remember, let's say that our number is 5. So then register 4 becomes equal to 10 times 0 plus register 3. So 0 plus 5 is 5. And then the next time we go through it, if we only typed in the one number, we're going to exit out. And then in the case of, like, if we type in the number 15, the first time we go through it, we're going to end up with the number 1. But then the second time we go through it, since register 4 contains the value 1 already, we're going to take 10 times 1, which is 10, and then we're going to add the new number to it, which is 5, I think I said, because I think I said 15. So that's what was going on, and let me just delete that comment out. So what I'll go ahead and do is I'll just go ahead and show that in the debugger really quick so we can see it. Let me save that. Let me remake GDB main, and let me just list this out and put a breakpoint. Let's put the breakpoint at 38. Yep. And then let's go ahead and run this, and let's start with the number 5. So after the MLA instruction runs, we expect to have 5 in register 4 because we're using register 4 to keep track of our total. So let's just quickly single step through there. So we're getting ready to run that instruction, and now we have value 5 in register 4. So now we're going to go through it again, but we're just going to exit out because at this point we will be reading the enter key, which will end up giving us a negative value. So we're going to branch to the exit. So let's continue through and let's run this again. Now let's do number 15, which in hexadecimal will be F because 10 is A, 11 is B, 12 is C, and so on. So let's go ahead and step through. So after the MLA instruction, we should have the number 1 in register 4, which we do. And when we run through it the next time, we're going to be taking 1 or 10 times 1 and then adding 5 to it, which will give us 15, or F in hexadecimal. And there we have it. So let's continue through to the end, and let's just do one more. So let's do the number 255, and that's FF. So let's step through quickly. I'm doing this a bit more quickly this time than I was in the other video, but I figure that's fine. Okay, so you can see we got the letter FF. So the point is this logic is now working as we want it to work. So let's continue through to the end. Let's quit out, and let's go back into our main file, and now we can continue on with our game. All right, so once we have handled the input, once we have calculated once we've converted what they typed in into a number that we can compare, we then need to move on to that comparison step. Now we need to have something to compare it against. And we're going to compare it against something I'm just going to call secret. And I'm just going to just giving myself more space here. We're going to compare it against a variable that I'm just going to call secret, and that's going to be hard coded for now. We'll be generating that number later. And for now, we're just going to use the hard coded value of 88. And here I could use int. I could use .word. Well, not like that. I could have used .word or a few other things, but in this case, word doesn't mean like a letter, like A, B, C, D, E. Which coming from C, you might think that word is similar to car or char, but it's not. It's just a space of bits, a space that will hold our bits. But we can also use int, and so I'll go ahead and use int just because I think it makes it a little bit more clear that we're just storing an integer value. Okay, so we've got our secret number stored. So now we want to have a place where we can load secret number. And to load the secret number, we're just going to load into register. So at this point, we can recycle all of our registers except register 4, because we decided up here that register 4 was storing that number. So all the other registers we can reuse. So let's just reuse register 0, and we want to load into register 0 the memory address of our secret number. And then we want to load into register 0 the value of our secret number. So that also means once we are at this point, we don't want to just jump to the exit anymore. Now we want to jump to the next part of the program where we're going to continue our game, which is like the compare step. So I'll just say branch to compare, and I'll put that right here. Because you remember when we're checking R0 or register 3 against 0, what we're checking for is the end of that string. So once we have found basically the enter key, now we want to, so that means that number is going to be negative. So we want to jump to this compare step rather than jumping to the exit. Okay, so now we have register 0 loaded with our secret number. So now we just want to compare the secret number. Compare input with secret number. So we want to say compare, trying to think of which way do we want to go, R4 with R0 or the other way around. I think we want to compare the secret number with what they typed. So that would be this direction. If I got it wrong, I'll flip it. So we're comparing we're comparing the secret number that we just loaded with whatever the user provided. And if the if what they typed is greater than, then we're going to jump to a section called too high. And if what they typed is too low, we're going to branch to, so branch less than, we're going to branch to something just called too less. Too low, not too less. And there's only one other option, which is equal. And we don't have to explicitly jump to that because it's just going to be implied. So for this section here, we'll just call it game over because it means the number matched. So we'll just fall into this section. And we'll put a message here. And then we need to have this too high section and this too low section. So we want to put some messages in here that say, you know, you won the game, your guess was too high, your guess was too low. And we've already done all that up here when we created this prompt. So we're just going to copy all this logic and we're going to bring it down here and reuse it 3 times. 1, 2, 3. So we're going to load into standard out. We're setting up the registers to print a message. And here we're going to just say we're going to say win message. And here we're going to say, just say hi message. And then down here we'll say low message. And of course we'll have to count those up. So if we're presenting the win message, that means the game's over, so we will unconditionally branch to the exit. If we're presenting the too high message, it means that they need to go again, so we're going to unconditionally jump to back to the loop. And then same thing if it's too low. We need to jump back to the loop so they can keep playing. All right, so that means we need to create these three messages: win message, high message, low message. So let's come up here and do that. So win message, high message, and low message, like so. Okay, so for this one, just keep these messages nice and simple. You win. And then a carriage return. And then if their guess was too high, we'll just say too high. And if their guess was too low, we'll say too low. These are almost all the same, but they're not quite. Anyway, let's count this one up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 characters, because remember, this is only the \n only counts as 1. So this is 9, this is 9, this is 8. So let me jump to the bottom and put those in before I forget. So 9, 9, and 8. Okay. So is there any issue with what we have here? I don't think so. Let's just try to assemble and see what happens. Okay, so it assembled, so let's test it. So let's go too low. So my logic is backwards. All right, so let's fix that first. So I'm just doing the compare in the wrong direction. So I need to compare 4 to 0, not the other way around. Let's rebuild and clear that out. And let's try it too low and too high. And then correct. Okay. And then of course, if they type in gibberish, yeah. So one thing that'll be good will be to have a quick way to exit the program, because if we are when we're generating a random number, we're not going to know what correct number to type in to quickly get out of the program. And when we're doing tests, we might want a way to just quickly check something and then exit out without having to actually play through the game. So when we gather up the input, let's check for an exit condition. Check for exit. So right after we get the input, but before we turn all the input into numeric values, let's check to see let's test for the letter X. So if they press the letter X, we'll say that they were trying to exit the program. So what I'll do here, and I did this before in the video that I have to delete because the audio is no good. I'm basically going to be reloading this byte like I did down there, and then comparing it against the immediate value X. But I found that in order to do that, there seems to be, and I'll have to read about this, but it seems to change register 1 when I do this. So what I'm going to do is I'm going to first copy into register 0 register 1. So I'm making a copy of register 1. And then when I And then I will, actually I guess I can just do that right back into register 1. So I'm making a copy of register 1 into register 0. Then I'm taking a byte out of, actually no, I don't want to change register 1 here. And then I'm taking a byte out of register 0 and saving it into register 2. Now I want to compare the value in register 2 against the immediate value for the ASCII representation of the letter X. And if it matches, if it's equal, we want to just jump to the exit, because we're saying, you know, it's like just a quick way to exit out of the program. So I think I got that logic right. Let's quit. Let's save, rebuild, and test our code. And let's make sure we didn't break this. So that's too low, too high. So it's all working. Okay. Yeah, so that just gives us a quick way to exit out. And then we can make that part of our prompt as well, but I'll worry about that after we get to the point where you don't have to manually count out these characters anymore. Okay, so that takes care of that. Basically, the game is done. We just now need to generate a number automatically so that we're not constantly just either changing this and reassembling everything. Obviously that's no good. So yeah. All right, let me just go ahead and stop here then, and when we come back, we will either start taking on a little bit of a cleanup effort, or we'll get into the random number generation. I'm not sure which way I want to go first, so I'll decide that between now and then. But thank you for watching, and I'll see you in the next video.